areas, what should be done, and so on. So that's one of the other areas, perhaps one of the areas where it's not talked about or worked as much by the technical side, especially when it's related to things like surveillance. Then everything connects together, and we should be looking at it more carefully. This is related to healthcare, but not just healthcare, but health, social media, relationships, urban areas, urban development, and so on and so forth. And of course, the economy. People coming in, they have to have jobs. The economic prosperity, determines a whole bunch of things in the smart cities and so on. So these are sort of the major areas where research is going on in smart cities, most of them involving the use of big data or big and medium data, however you want to call it, and artificial intelligence. Okay, let's see, next, yeah. So some of the technologies that are being used are, of course, sensors, and these can be all sorts of different types of sensors. The most ubiquitous among them are cheap cameras, but it could be even sensors such as ones trying to capture your image, the image of your face, but trying to capture the heartbeat from the image of your face. So you can actually detect your pulse rate. There are gadgets which can be applied to get your pulse rate. But one of the types of technologies that I would like to introduce or talk about that's increasingly getting more and more important, and we need to address issues related to it, especially in the gathering the data and using the data side, is beacons. So these beacons are there in the smart cities, and the objective is to allow individuals to connect to each other and to connect to their surroundings. So in essence, the individual is getting connected to some beacon on a building, and then from there gets connected to other entities. Now, the type of beacons that are being used are usually Bluetooth low energy beacons. So these are wireless radio transmitters. So it sends an ID to a nearby receiver, and it can potentially trigger a number of applications in whatever devices that either you are using or is in the smart city, in the building, on the road, and so on and so forth. Some of the applications of this technology is proximity marketing, so that when you are walking by some restaurant, and maybe it's that time of the day, lunchtime or something, it'll use the information that you are in some area to say, hey, there is a Thai restaurant, 3 floors above where you are, and maybe you want to go there. It has food, and if that's coupled with the data that hopefully they asked your permissions to get about your likes and dislikes of a particular type of food, it will result in good, hopefully a good outcome. Another application is indoor localization and navigation. So we have pretty good navigation tools if I use Google Maps to go from one place to another, and it works pretty well, let's say 95% of the time or more. However, when you're inside a building, especially in a large mall, I'm like, okay, where is this? I read the map, and then I try to go there, and then I forget, and then I am lost. I have to ask someone. So the navigation part, in some large malls, I've seen that actually even Google Maps, the point goes across and I can make sense. But if you're talking about large, not in a horizontal sense, but in, let's say, a vertical sense, a tall building, and you are going up and down. So that type of navigation isn't there yet. And with the beacons, it can be done. Now, these are the good things about these are that they are small, low cost, and have minimum energy requirements. And so this is, I won't talk about the topic in great detail, but we had worked on, I don't know, maybe 10 years ago or something in sensor networks on how to route messages so that the lifetime of the sensor network is maximized. So if all the messages go through one particular sensor, then that sensor would lose its battery life pretty quickly, and it dies, and then you have to replace it or so on. So at that point, the sensor network isn't working very well. So we found out ways to move messages based on the amount of battery life and the power needed, and so on, how far it is going, where it is going from, and so on and so forth. Now the research is there where people are looking at sensors, let's say in farms, which are maybe self-generating and recharging using either solar power or sometimes thermal power, sometimes maybe in the future obtaining power from people walking by or whatever else they can grab power from. So these are very low amounts of power that they can grab and recharge these cells. So those are the good things. Now, as we will see with all the technology that I talk about, there are issues related to the privacy and security concerns. And in this case, with the beacons, all the information, and the case, as is the case with wireless communications, is there is no wire to guide the signal from a source to a destination and only through that route. It's a broadcast medium. And in broadcast mediums, there are these privacy and security concerns that need to be taken into account. And some other applications that are important and active areas of research in smart cities is smart transportation. And I was working with a company that was building software to essentially predict when a bus will come and do routing and so on very precisely. So when you see, in some of the smarter cities, you will see it says, okay, the nearest bus, or in any of the metros, you will see the nearest bus, or nearest, the next train is in 5 minutes. Okay, so that is perhaps easy to do if you know, okay, where the train is. And maybe if you say the next train is in 10 minutes and it becomes 11, people don't mind that much. But we wanted to see how far we can push the technology and how accurate we could be. And you want to be accurate because, well, you want to use that perhaps for decision making. You want to see whether you should take this line or that line, and whether you should take this bus or maybe even drive or walk, and so on and so forth. So we know that accurate predictions of transportation motion transportation modes is very useful. But in this case, the problems that we were running in where, let's suppose the bus is going from one end of the city to the other, and you need to provide an estimate of when the bus will be somewhere else. Now, we know that it will take about an hour to go across the city. And it's 4 o'clock now, so there is no traffic jam. And you do the routing based on the current traffic. Of course, you'll be wrong, because at 5 o'clock towards your destination, there'll be people coming out, and the last 10 minutes might actually take you half an hour to get there. So that's something which we can tackle using historical data. And then with the historical data, you perhaps have to use the context saying, oh, this is a Monday, but it's a holiday. And so it will not have that many people coming out at this side of the town, things like that. So all of this is being done. But the hardest part is, and you can predict that, okay, 5 o'clock, people will come out of their office. But the hardest part happens when you have accidents that might not have even happened. So I'm going from this side of the city to that side of the city, and an accident happens in my last 15 minutes, then that last 15 minutes takes 45 minutes. But when the bus is starting, how do I know that an accident will happen? And you can say that, well, okay, the accident might not, will possibly happen or not happen, and it was just your bad luck. So we just predict based on normal circumstances, and we are fine with it. But can you do better? Can we say that, well, this is a part of the town. If you're going from this end to that end, there is maybe a 30% probability that one accident will happen on the way, and each accident in any part of the town will, put you back by 20 minutes. Something to that effect. So that it's almost like predicting that an accident will happen. We don't know where, when, but doing things based on that. And one of the topics of research that is very close to my heart, I've worked a lot, is on data integration. There is, of course, fantastic work being done, including in some of my students, on trying to put in information together from multiple sources. So for example, one of my students was looking at wind data and pollution data and historical wind patterns, and predicting that, okay, tomorrow morning at 5 o'clock, the wind will blow in this direction, and because there is pollution there, it is going to come in tomorrow morning, but tonight the wind is blowing in the opposite direction, and so the pollution will not come in. So he had, and if anyone's interested in the work, I'll be happy to point you to the paper. So essentially, multimodal, multi-source data integration is a crucial backbone to a lot of cutting-edge data analytics that needs to be done. Another example, important application in smart cities is smart water systems. And in this case, my lab has some work on looking at essentially the cybersecurity of energy grids. So lots of people have done work on trying to protect energy grids and the cybersecurity of energy grids. Now, and then lots of people have done with work on data analytics for water supply, improving the water supply. I think I mentioned later on that the city of Dallas had looked at water usage, and by analyzing things and intervening fast, they were able to cut down waste by a large amount, 75% or something like that, with a small amount of investment. So there is work on water, and there is work on energy. One of the projects that I have involves looking at, so it turns out that when hackers attack energy grids, it's actually, there is some relation between the water supply and energy. So you could actually cause more problems that will cut off water and your electricity, and cause the, essentially what they do is they cause some of the entities in the grid to falsely think that there is some outage, and that shuts down. And so it trips, and so that there's no huge electric flow on those parts of the grid. And then there are cascading shutdowns, and this hack can actually go in cause problems with your water supply by going into the water supply control grids and affecting them. So some of the work that we are doing is in this area, and I'll be happy to talk about in more details. So what are the challenges in related to this data security in data integration and interoperation in the smart cities area? So the data is multimodal. It can be numerical data, it can be text, it can be images, it can be different types of numerical data, and it's heterogeneous. The measurements can be done using different types of devices and at different time frames and so on and so forth. And it is noisy and incomplete. And sometimes the data isn't there. And so this is not in a smart cities area, but one of my students was working on looking at wildlife movement patterns, elephants in Africa. And we were trying to figure out why are the elephants moving in this particular place. And we needed to find the temperature data. The temperature data was there, but it wasn't there at that granularity that we wanted. So we'll have to do some extrapolation and make some decisions as to how we can best predict come up with the temperature at that time, at that place, and then use it. It's dynamic, and sometimes the data is crowdsourced. So it's provided by volunteers. For example, in the bus scheduling case, we were having people enter the times when they got down from the bus, or if they saw an accident. So it can be unreliable, and it requires near real-time analysis. So in the bus scheduling case, again, these decisions need to be made within 30 seconds and so on, because you need to get back to the user and provide an answer. And you don't have the time sometimes, or the capacity on your edge devices to do the computation, and you don't have the bandwidth and time needed to go back to the servers. Of course, as I mentioned, privacy and security are important issues, not only with individual pieces of data, but when we integrate data from multiple sources, inferences can be made, and we actually can know a lot more about a person than if you just look at one piece of data. Data can be biased, especially in the machine learning world and the AI world. If you build face detection tools that are only used to seeing Caucasian faces, it'll possibly not do very well if you have people of color whose images you're taking and trying to figure out whatever you are doing. The system was trained on using the Caucasian faces. Okay, so some more applications. These are now a little bit more futuristic. Some of it is already happening now. Is predictive problems. So can we detect air and water pollution even before it happens? So right now we were going towards that by saying that we'll use the wind pattern to do some amount of prediction that doesn't follow directly from the traditional prediction, from the historical data, because the wind pattern has changed, and we know whatever the wind pattern is right now, and using that information, we can make much better predictions than before. But I can now I can predict that tomorrow morning this is going to happen because I have some information now. Again, disease hikes and spreads of diseases, to some extent you can do. You can say, well, okay, the peak is going to, now you're having this big social event where 100,000 people are gathering. So maybe in 2 weeks' time, you're going to have COVID and so on. So once we have these models, we can make these patterns, but the idea is, can we do that on a large scale? Or maybe even on an individual scale, where we want to predict, let's say, a heart attack 20 years before it happens, and then have some preventive measures taken. Smart cities safety is an issue. So in this line of work, predicting where and when there is a high probability of crime happening, and are detecting, from the events that have been provided, trying to come up with sort of hubs of crime, or where should we place, let's say, the peace officers, so that we can prevent crime the best. I talked about the water monitoring done by the city of Dallas to detect waste and reduce waste as much earlier than they were before. So this is a project which was done in the UK, and I think in Sydney, Australia, where they deployed smart street furniture. So essentially, you have a park, you have a bench that is sitting, by the road, and that comes with charging ports. It comes with free Wi-Fi, and so on and so forth. And the smart furniture, they studied who were using it, what's going on, and most of the people who were using it were, living rough, homeless, young people, students, and gig workers. And they were using this to stay digitally connected and find information, or even listen to music, whatever they were doing. Excuse me. And in some cases, you don't even need to own a phone, or you didn't have the amount of credit to use it, and you can use this. So this actually, I have used similar things when I'm traveling, and I didn't want to change my SIM card. My US SIM wasn't working, or was too expensive, something like that. And then, so these, I would go to those places and then get connected and get the free calls or the internet connectivity that then let me find, what time the bus is, or whatever other routing information that I needed. So in this case, it is helping people to be connected and, getting them the information, hopefully enriching their lives. And this is a good thing that it's, doing this to this group of people. However, the point is, what other data is it capturing? And is it taking my weight? Is it, will my insurance rate go up because I'm not walking enough? It figures out that I've been waiting in this place for a long time, and so on. Okay, sure, I will do that, and so on. So that's essentially one of the one of the issues, in the sense that, are we surveilling the poorer and the younger people and the lower in our society with these smart city devices? And so is that ethical? Because they are the ones who are being caught in these surveillance devices. Okay. Since I'm running out of time, I will just briefly mention some of the non-technical challenges first, which is we need to get citizen buy-in. Once there are regulatory barriers as to how to use the data, for example, GDPR or CCPA in California, it becomes harder to implement the smart city solutions. There are large cybersecurity risks because we have gathered all of this data. And even if the government itself is not surveilling or trying to, somebody in the government is trying to take their vendetta out on you, what happens is there are these hacks and leaks, at which time, let's say the credit, the credit agencies, they collected all this data on us. Some third party hacks into it, they get all the data about us. And what they will do with it is not known. And then funding issues. 5G, I will not click on it and go into it. So 5G actually allows us to do these things much better. The rates are faster, reaches longer distances, and so on and so forth. So I talked about this, about data, and I will skip over these ethics questions. So Singapore had similar things about a smart lamppost. So they said, well, we are looking to improve services and how to run the city, and we have no plans on moral policing or things like that. Okay. Same with smart lamppost in Hong Kong. So they said, well, we are going to disable surveillance features using license plate recognition and so on and so forth. And well, of course, we don't know what's going to happen if the government changes and there is pressure from somewhere else. And so I think if I can quickly show this, this is too small. So let me try to share my entire screen, and then I'll quickly show this on, this is the Chinese social credit system. And okay, this is sort of annoying. Okay, so this is the Chinese social credit system. So where positively influencing one's neighborhood, your credit score goes up. Taking care of the elderly, your score goes up. Engaging in charity work, your score goes up, and so on. And on the other side, there is the negative scores. And if I can go there, I can show you some traffic offenses, jaywalking, and then posting anti-government social messages on social media, spreading rumors on the internet, insincere apologies for crimes committed. You're cheating in online games, your scores go down. And you have that credit score. And then citizens are blacklisted and so on and so forth. So the question is whether we are ready for such type of invasive data collection that inevitably would happen with smart cities, and or what protections we would want. And again, I will not go into these. I will go into my sort of last slide in the interest of time to give some time for comments. And so this topic is important because in most Western countries and in a lot of places over the world, because of better healthcare, the population is aging, and the urban population is aging. And can we use the smart cities system that we built to actually help the elderly in many ways than one? And one of the issues that I'm interested in is essentially need for a fall detection system. So once I'm looking this way because I can see the street from my window, and once I have my sensor there, and is there something in the fall of somebody having a stroke or some pattern that can be detected and immediately an alarm raised, which can result in time saved and lives saved. So if we have the sensors all over the city everywhere, can we use that to help the elderly? I think the answer is yes, but we just have to connect all the software, and once you do that, we'll have to figure out how to run all that in these small devices, or what we need to push to the edge computing devices, and what cannot or should not be pushed to the edge. So some amount of design and research needs to be done in this area. All right, with that, I think I have about 5 or 6 minutes for questions. I'm happy to engage in any comments and questions that people might have.
I have, first of all, let me ask you a question from my own experience. I have seen that working on smart city projects, like if you're working on a particular problem, you develop, work on it, and you develop a prototype, or you think that may be a good solution. But the next problem is, how do you implement it? Actually, have you seen any real world implementations of the various projects that you have worked on? How it is being funded, and so on and so forth?
Well, I have not had the success of, or maybe I have not tried in implementing it, but I think the local governments are some of the places to go to. And I know that some folks at Penn State have worked with the City of State College to get some of these projects in their hands, and being at least used in a pilot test case related to parking and traffic and so on and so forth, and have worked with police and so on with respect to crime, and solving some crime. So I think we will have to build these relationships with the government entities and educate them, and then hopefully have some limited pilot tests, and if it works, then deploy it.
Yeah. Now we have a few more minutes. We can take a couple of questions from the audience.